Welcome, everybody. Nice that you joined our talk. Today, we want to talk about how IoT can save a life. We want to show you a real-world use case we realized in our company. But first, I would like to introduce ourselves. This is Guido Grune. He's a software developer at Data in Motion. I'm Mark Hoffmann, the CTO of Data in Motion, and we are working with modular software, especially OSGI and model-driven software for years now. And we as a company are heavily involved in a lot of open source projects, especially Eclipse Sensinact, which is an IoT broker, but also in the OSGI working group. And we are also involved in OSGI technology projects and contributing to several other open source projects as well. The use case we want to show you is from a research project from the last years. It was about smart cities and 5G related topics. And this is what we want to talk about. First, I want to show you how a city looks like and what, when we talk about urban data platforms or smart cities, what is it about? There are a lot of buzzwords around in the world: digital government, smart cities, digital twin, AI. But in general, you have a city with maybe hundreds of things and assets you might be interested in when we talk about grabbing data, analyzing data, something like that. In general, we have data that doesn't change that much over the time, but on the other hand, in the smart city area, many cities starting having sensors all over the city, and these sensors can collect data with a high frequency. In our example, we want to talk about traffic light controllers and also traffic cameras, but you can also collect data from smart meters or moisture sensors or whatever you can imagine in such a city. Another big topic in regard of smart cities is when we talk about public areas in cities, we talk about public money. And we also talk about public data / open data. And in the end, everything should become also public code. This is always a good idea. Our use case is about the city of Jena in the center of Thuringia, so nearly 400 kilometers from here. And it's a city in a valley, and we have more than 100,000 citizens in Jena, and just 1/4 are students. And it's a city usually with students with a lot of bicycles. So as well, we have traffic. We have a lot of intersections, and what we wanted to do is collect the traffic light signals and also the corresponding detector buttons and also acoustic sensors on intersections. And for the cameras, for instance, we had a demand to have a classification of vehicles, of assets, classification of persons, bikes, or determine if you are a truck, a bus, or an ordinary car. In addition to that, the cameras should detect the movements of these objects, so we have object tracking there. But the same applies to the public transport. We have trams, we have buses, and we want to transmit all their geographic geopositions and the next destination, for instance, next stop, sometimes the door state. And eventually the timetable. These are also information that we want to collect in a city. Yeah, and beside that, we also have moisture sensors for trees and watering trees all over the city. We have environmental detectors, and yes, and also sensors for waste bins and many, many more. So as we see, if you have a smart city, you have a wide variety of things that provide information to a city in various ways, in various protocols. And because of that, usually these sensors provide the information in an event-driven way in a relatively high frequency. So, and for that, we use an open source project called Sensinact. Maybe if you're interested, there's another talk about the Sensinact IoT broker this afternoon. And Sensinact is a good way to collect all the data. We have the possibility, we have a general data model in the Sensinact core, and we have adapters for any protocol you can imagine. In our case, we used MQTT to submit the events, and we got information from, in our case, three major parts. One is called ILSA. Guido will talk about what it means, and we get the information from the ILSA is for the traffic light controller data, and the next thing is we got traffic cams from a certain vendor, and we collect the movement information, classification information. And the third one are information from public transport, from buses and trams. EBIS IP is a standard that is used internally in buses and trams. So, and in general, we try to collect all these different data sources, and we route it into the Sensinact broker. We have the possibility to have a historical data management. We have some kind of digital twin. We have a general data model for our sensors in Sensinact. So whatever comes in, it has an intermediate model, which is the digital twin. And then we can do anything we like with all the sensor data within Sensinact. And we use that to combine data from different sources. How do we get that achieved in more detail? I would like to hand over this to Guido.
Thanks, Mark.
It's yours.
Hello. Yeah. We have integrated lots of data, sensors and devices in our platform. I've picked three of them, hopefully interesting ones, so I can show you how we started with some recommendations from the city or from the project, and how we finally realize these projects or these integrations to our platform. Let's start with the ILSA, in German intelligente Lichtsignalanlage, intelligent traffic light controller in English. It's just a traffic light system for a whole intersection. The one we are talking about and we are working with was a Siemens device. The city of Jena uses Siemens traffic lights all over the city, and so we have something really proprietary, undocumented in front of us, and we know that this hardware is critical and should be handled with a little bit caution. So we don't was allowed to modify this hardware or this internal software, and but the requirement for our project was to get the data in real time, as nearly real time. So we decided to bypass the signals, and as we want to integrate not just one single traffic light system, we have another requirement to minimize the effort, the hardware and the affordable to be low cost, so we can deploy it on different intersections. And as we've seen in the Sensinact, we can handle our objects and data as a model. So we decided to just transform our data in an EMF model to send it to the MQTT broker, so it can be handled automatically by the Sensinact on our urban data platform. Another limitation we have, we are out in the field without any network connection, just a 5G mobile connection, so we have to take care about the amount of data we are sending between the different actors. And as we started, we didn't know not really much about our system. We are try to integrate with, and as that, we got some help from the community of Jena. We get a traffic light simulator from them, and we try to develop a connection so we can get the data from there to understand how the protocols are working and how we can get the data in a reliable way out of these proprietary system. The first step was that we take some hardware from our office, a simple Raspberry and an ESP for the first approach. With our knowledge about the Eclipse IDE and the BND tools, we have really a simple and fast and reliable working development environment where we can deploy and debug via remote to the Raspberry device, and so we have a life cycle for our source code that's really short, just saving your source code in the Eclipse IDE, deploys it on the Raspberry, so you can check and reverse engineer a little bit easier than just to copy and paste something from one device to another. So it helps really much to make some progress. That was our first attempt, our prototype. You can see on the left side just a small ESP development kit. On the right side, our Raspberry, and with an LTE stick in it. So that was the first approach with an adapter, so we can connect it to the traffic light system from Siemens. After we have enough knowledge about the protocols and how we get the data out of it, we found a better solution so we can deploy it not just as a prototype, because we try to minimize the efforts and the costs. As a result, we find some little gizmos that just pre-processing the data from the traffic light, and as a next step, the pre-processed data was filtered, validated, and transformed in an EMF object from the Raspberry and sent via MQTT to our data platform or Sensinact. At the moment, we are developing a back channel, so we can send a request to the traffic light system to switch to a certain phase. That one will be realized maybe next week if everything goes right. And hopefully there can be some more possibilities for the city to optimize the traffic flow through the city with these possibilities. So that's the one finally installed in the traffic light system. It's a Revolution Pi with an LTE stick, and as an adapter and preprocessor, we have used this little Atom one. Well, wait a second, maybe, yeah, this one. If you want to take a look at it, just come around. We can show and talk about it in technical. As a second example, I will talk about a traffic camera. The city, with the same intention as with the ILSA, wants to optimize the traffic flow through the city, and therefore they need some data about the moving objects. They want to classify them. They want to analyze the movement through the city. As an example, we have some train stations and some bus stations, and the movement of pedestrians between both is interesting for the city because there are some roads between them and with cars, and optimizing the traffic light phases and the flow of the cars would be very, very helpful to minimize any traffic jams or something like this. What was the requirement? As with an ILSA, we want real-time processing. We want the data in seeing live somewhere or using them as for other proposals. We want the classification. We want to know, is it a car, is it a pedestrian, is it a cyclist, or where it is, how fast it is, and in which direction it's moving, what's the heading. And all of this has to be GDPR conform because we are monitoring or looking at persons that are maybe not interested in saving their personal data. The city has the requirement of installing 17 cameras at the moment. So it's not just one single prototype we are talking about. We are talking about a whole network of cameras, and all of these has to manage and deploy our software. The realization was via a FLIR traffic cam. The decision about the cameras was made by the city, so we have just to adapt to them. We are taking the same Revolution Pis as we used in the ILSA, industrial hardened and reliable. As a first step, we are getting the configuration data from the cameras, so they have their own position, they know which angle they are looking at, they know the observed area, and all of these data is helpful for us to position the objects the cameras are seeing. The objects were detected by the cameras are sent via WebSocket stream out of, so we can, as in the ILSA, converted it to an EMF object and sent it via MQTT to the Sensinact. Okay, that's one of the installations, a little bit strange one, yeah. Installations in the city. You can see the power converters just on the right side. There's the revolution pipe behind the cables. On top there's a 5G router and a small switch. And all of this powers up and collects the data from these two cameras in an example. On the crossroad in front, there are 5 additional cameras, and so we have a small network in the city of Jena where we can live track any moving object. As a third and last example, we have some moving data source. We have some buses and trams from the public transport, Jena. We want to know how, where they are, how fast they're moving, if there are customers in there, what's the next stop, are the doors opened or something like this, customer information just showing in the train. So we want to get them out and make it available in public. The special something special one in this vehicle was that we have special hardware. In this case, a special router. We don't have we wasn't allowed to modify the hardware. We wasn't allowed to modify the integrated system, but we could deploy. Maybe that final will come in the realization. We could deploy some LXC containers, so we have some abilities to deploy our own software. So we started with the ILSA with a prototype because of some licensing problems at the public transport company. But finally we deployed our OSGI environment on the net router in an LXC container, so we could communicate with the onboard computer via EBS IP and get the position from the GNS multicast, and as in other projects, transform it to an EMF model and send it to the MQTT and to our platform. This one is a prototype. Yep. First step, just a little Raspberry Pi with a 4G mobile network connector, thanks to Huawei. And for the power consumption, because we have some problems with the stability of power in the trams, we have put a power bank between the car connector and in our Raspberry. It looks a little bit punky, but it works. But how saves this data lives?
I think you will show a video.
Yeah.
So by the way, you may see this small image here. This is these are the real-time data from an intersection in Jena. It's really real time. So you will see something on the next video that shows what we did and how we can save lives with all that stuff. So maybe?
Yeah, we have a small video comes on a little bit after. We have a small intersection in front of our office
Yeah.
where cars and bicycles and pedestrians are crossing, and we have a problem that cars and bikes have both green in the same in the same moment in the same direction, and if one of the cars have to turn to the right, it can be a problem for the cyclist that he will end up in a crash. Between the road and the bike lane, you see the trees, and yeah, that's why the car drivers didn't see any pedestrian or faster traveling cyclists.
Yeah.
So we added another. We subscribe to the data from the cameras and from the traffic lights. So we know when the traffic light is green for the cars and for the pedestrians or for the cyclists, and we know if an object is moving in the correct
in the right direction.
In the right
through
direction.
The intersection and not away from it. So.
And with the right speed and with the right direction, and aggregating this data, we have the possibility to know if there are a possible conflict and could give them a signal so the car driver or the cyclist can react.
This is how it looks from a technical point of view. For someone who's interested, it's we just subscribe on two topics: one for the traffic light controller, second one for traffic camera, and then we have just an evaluation for the virtual sensor that then says, okay, this is a conflict or not. This is some kind of pseudocode. So now the video comes.
Now, 80 seconds. That's
so what you see is exactly that situation. You can see the cars waiting for a green light, and we also see that the traffic camera looks not on the street, it looks on the way for the bicyclers and the pedestrians to detect people. I think
now they have green, the cars and the pedestrians.
Yeah.
You can see it here, and on the moving cars. And on the bike lane, there's a cyclist arriving.
And a special thing happens here. Now we have a detection that a bicycler is approaching, and now we have in our virtual sensor the conflict attribute set, and this is exactly what we wanted to achieve. Finally, now you can decide what happens with that information. So if you put some flashing lights on the street, or sending an acoustic signal, or sending some information into the car, it doesn't matter. But the first step is to have that information that there is something wrong or a dangerous situation. So in the conclusion, the possibility to create virtual sensors in such an easy way, especially in products like Sensinact, makes it possible to realize a lot of use cases. So, and especially in that case, there's no need for having an AI. If you have the right information from many sensors, you can combine it sometimes in an easy way without having such fully blown machine learning decision thingy. And the best thing is everything that we have seen can be run on a Raspberry Pi Zero as well, directly locally on the intersection. There's no need to run it on a back-end system or something like that. As an outlook, we have seen we also collected the data from public transport, from buses. On the same intersection, we also have a tram track, also with traffic light controllers, and we have the same dangerous situation over there. So if we know the positions from the tram that are approaching and people's crossing the tracks, then we can just sending signals in a way we like. So this will become one of the next steps we want to realize. But also with the tram information, we can help to ease the life of, for instance, disabled people or people that don't speak our language. We are in Jena, in the middle of Germany. We don't have English information on our trams. So if you are from a foreign country, it would be nice just to have a Jena app and just saying, okay, I'm in that tram and the next station is, and I want this in French or in English. So, and I think this is also a good possibility how to use exactly these data in an easy way. So, that's it from our side. I hope we have shown you a little bit of our use cases, and maybe you have questions, then please join us to the stage, I think. Yeah, thank you.
Thank you very much.